Okay, so you probably think of a function in math as just a simple rule, right? You put one thing in, you get exactly one thing out. But what if I told you these rules have different personalities? Seriously, some are super exclusive, some try to cover all their bases, and some are just a perfect match. Today, we're going to break down these different ways functions pair things up. Let's dive in.
So, to get us thinking, here's a little riddle for you. What on earth could your student ID number have in common with, say, a flawless, perfect matchmaking service? I know, they seem like they're from totally different worlds, but believe it or not, they share a fundamental mathematical secret.
And the answer is, they're both amazing examples of functions in the real world. It all comes down to these really specific rules of assignment, how one thing gets paired up with another. And once you get these rules, you'll see how everything works.
All right, first up, we've got a rule that I like to call the no sharing rule. This one is all about being exclusive, totally unique.
So the official name for this is a one-to-one or injective function. And the rule is super clear. You can't have two different inputs ever leading to the same output. It's just not allowed. Every single input gets its own exclusive result, guaranteed. And you know, this whole idea of guaranteed uniqueness, it's the absolute bedrock of any system that needs to be reliable and unambiguous.
And this is the perfect way to picture it. Just think about it for a second. It would be total chaos if you and your friend had the exact same student ID number, right? Of course, it's one student, one unique ID. That's a classic one-to-one relationship. The input, which is the student, is tied to one and only one unique output, the ID.
So how do you spot one of these in the wild? Easy. We've got this super handy trick called the horizontal line test. You just take the graph of the function, and then you imagine drawing a straight horizontal line anywhere on it. If that line hits the graph in more than one spot, bam, you've broken the no sharing rule. It is not one-to-one. It's such a quick and simple visual check.
Okay, let's move on to our next type, which kind of builds on this. This one's all about making sure nobody gets left out. Let's call it the covering all bases rule.
So this is called an onto or surjective function. Here's the deal. Think of all the possible outputs a function could have. Well, an onto function guarantees that every single one of those possibilities actually gets used. Every potential output is hit by at least one input. There are no lonely, unused outputs left hanging out.
Let's look at this side by side. On the left, see that function that isn't onto? Notice that little output at the bottom with no arrow pointing to it? It's been left out. In this case, the set of actual outputs, we call that the range, is smaller than the set of all possible outputs, the codomain. But now look at the right. That's an onto function. Every single possible target is hit. The range and the codomain are exactly the same.
Okay, so we've got the no sharing rule and the covering all bases rule. So what happens when we put them together? Well, you get the gold standard. This is what we call the perfect pairing.
To get this perfect pairing, we have to start with our first condition. The function absolutely must be one-to-one. And remember, that's our no sharing rule. Each input has to go to its own totally unique output.
And then we add our second condition. The function also has to be onto. That's our covering all bases rule. We have to make sure every single possible output is actually being used, no exceptions.
And when a function meets both of those conditions, voila, you've got yourself a bijective function. This is it. This is that perfect matchmaking service we talked about at the beginning. Every single person in one group is paired with exactly one person in the other group. Nobody gets left out, and nobody has to share a partner. It's a perfect one-to-one correspondence.
Whew, I know that was a lot to take in, so let's just pull it all together with a quick little cheat sheet just to help make sure all these ideas really stick.
So here it is, all in a nutshell. One-to-one means no shared outputs. Think of your unique student ID. Onto means every possible output gets used, kind of like filling every single seat in a movie theater. And then bijective, that's the best of both worlds. It's both one-to-one and onto, creating that perfect match. This is a great little summary to keep in your back pocket.
And I'll leave you with this one last thought to chew on. A bijective function, our perfect pairing, creates a relationship with zero ambiguity. None. You can always trace an output perfectly back to its one and only input. So, how might that exact property be the mathematical secret behind something like cryptography and keeping all of your digital information safe and secure? Pretty cool stuff to think about.